sometimes to turn YouTube on. So yeah, this is kind of the last week of summer camp coming up. So we're gonna do a chess tournament on Saturday. We've done these before. They're a lot of fun, actually. We host them through chess.com. It's a live tournament, so you have to kind of like show up on time. If you don't show up on time or you show up late, you can't like enter the tournament. So, but the registration starts like an hour beforehand, so you have plenty of time to get ready for it. We're gonna give out points for people that play games and win games. Also, I'll do another $10 gaming gift card giveaway, and the entries you get that will be equal to the number of games you've played plus the number of games you won. So there's a little bit of incentive to win. Yeah, chess tournament. Yeah, so please come join this. I'll make an announcement like server wide. This was just done in the summer camp thing, but I'll make an announcement on the entire server about it either tomorrow or something. But yeah, it's free to enter. All you got to do is just go to chess.com. Here's the link to our chess club. If you want to go join our chess club, that's how we do things. Here, it's verifying if I'm human. I have to log in on this. I think that's my password. We'll see. I'm already a member of this club. Okay, cool. Yeah, here we go. Yeah, so this is our little chess club. We started this last year. We did. Yeah, we've already done like 3 little chess tournaments. Yeah, definitely come by, play for fun. Yeah, for sure. Yeah, guy who got banned was playing with 95% accuracy each game with low rating, which is why I got caught. Yeah, don't cheat. Chess.com can tell if you're cheating. Also, I mean, this is a pretty like low stakes thing we're doing. Oh, do I have to like... Oh, here, I have to accept the request. There you go. Now you guys are in the chess club. Yeah, nice. But it's going to be standard 10-minute Swiss. So I think, you know, depending on the amount of people that enter the tournament, will determine how many games we play. So if 8 people enter, I think there are 4 games that get played. If 10 people enter, there's 5 games. So more the merrier. Always fun. But yeah, so... in Discord, if you're part of summer camp, you'll see the links to this. Otherwise, I'll post it on the server-wide announcements later tonight or tomorrow. But join up. And then, yeah, Jackbox games we'll have on Sunday. Again, very easy to sign up with that. You just need a browser in order to play. It's very easy. And then, yeah, as an additional bonus, if at least 5 people join up for Jackbox on Sunday, I'll do another $10 gift card giveaway for everyone. So, yeah. Summer camp ends. Yeah, summer camp ends technically next Wednesday, because that's when I'm heading off to Burning Man. And, yeah. Sorry, let me make sure my YouTube chat's working. What's up, Sib? Good to see you. Big Monkey Man says, I'm seeing all the exam results and college acceptance videos recently from the UK, China. I still gotta wait another 20 days. I just want it to happen already. They're stressing me out. Oh no. Yeah, I know. The whole waiting game with college apps is super annoying. Yeah, I understand. Just always trust it like you did your best. And whatever happens, happens. You know, it's either meant to be or it's not. So... I remember also as well, when not as much for undergrad, but definitely for grad school, there's this forums website called, I wonder if it exists anymore. It was called Grad Cafe. Does anyone know about Grad Cafe? Yeah, here it is. Yes. So this website, which I think used to be, yeah, it was mainly a forum is what I remember. But this is where people who are applying to grad school would talk about where they got accepted and whatnot. So, I don't know, if you end up applying to grad schools, Grad Cafe, I remember, is the kind of the little commiserating stress fest, if you want to talk about things. Yeah. But don't worry. Yeah, you'll be good. You'll be good. All right, let's see. Any other things that came up? Yeah, so stuff happening over the weekend. Oh, I will also announce, I think we're going to try and do a talent show as well. I'll announce that tomorrow. I don't want to burden you guys with too many announcements on, like, one day. I realize I'm catching up from the weekend, but we'll talk more about that, like, on tomorrow's stream. And then, yeah, if you've been working on the Kudu Physics Challenge stuff, that stuff is due on Friday. I gave credit for the Math Challenge stuff today. So, and yeah, I see some people already asking some questions during office hours about that, because I understand some of you guys have not even taken physics before. So this is a great opportunity for you to learn. What was the last best talent you saw from your last summer camp challenges? So I think we have all the videos recorded, and then we probably have, I say who won. So I don't determine the winner solely. It's like me and like a panel of judges, maybe Sensation will join us as a judge. And then you guys, the students, also vote, except you can't vote on your own. So every time someone submits something, everyone else except you will vote on your talent. We've seen everything. I've seen everything from like piano playing. Sometimes someone will play a cool anime song that people recognize. Or I've seen like live painting. Like someone did like a recording of them painting something. Music stuff, yeah, is always great. Some people submit like really nasty, like, you know, headshot clips that they got from, you know, some OP rounds and whatever Fortnite. That's also cool. I've definitely seen that one. I've seen all sorts of fun entries. I think I have a video of it. One second. Let me see if I can go find it for you guys. It's then you got to rethink everything, Monkey Man. You know, life does throw us like curveballs, is what I would say. Yeah. So even though, yeah, there is like a low chance that you don't get into like one of the places you want to, it's okay even if that does happen, because it's not like you have to rethink everything. You may just have to delay a year is all that has to happen, which is totally fine. Usually, you know, that's a year for you to go maybe get some more research experience doing something else, or taking some community college classes somewhere, or whatever. Like, it's totally fine. Don't feel like your life is over because, I don't know, some dumb person who looked at your app for like 3 minutes on an admissions board like said no. It's okay. Like, cream rises to the top. If you're meant to be there and you're meant to do good things, like, you will get there. It might not be like right away, but you will get there. What was I trying to find? I was trying to find, oh yeah, our talent show. Sometimes getting older helps. 100%. Yes. Yes, Sib. Yeah, exactly. Honestly, when I was, you know, in my younger years, I did a lot of dumb stuff. So having the maturity and like getting older sometimes gets you a much clearer and better perspective about what's going on in the world, and that can help you make the right decisions later, or like you're more ready for them. In my country, it's exam results only. Pretty much imagine if the only thing that matters on your entrance is your SAT score. Yeah, I understand. Yeah, that's unfortunate, but sometimes that's all they can do, right? Because it's hard to, you know, extracurriculars and like letters of rec like don't really matter. But yeah, I agree. It can be annoying that everything like comes down to like just a single test. I'm trying to find my talent show. Talent show. Yeah, here we go. I have a couple of them. I think they're private links because, yeah, they're blocked. Yeah, because some people would put like copyrighted music in their submission. So here, I can copy it for you guys if you want to see it. Yeah. Nice, good, Sib. Yeah, submit a question. I'll do it. But yeah, if you want to enter our talent show, there are some previous talent shows that happened 2022, 2024. You can kind of see what other people did. Okay, let's start off. You guys got some good questions coming up, so let's get things started and help you guys out. All right. Welcome everyone to Office Hours. My name is Dr. Phil, Action Education. The stream that helps you with math and science homework. What's up, Sensation? What were you gonna say?
I was gonna say, check out my latest work.
What's your latest work?
Before you start.
Okay,
it's
let me see it. All right, let me see it. Ooh. Oh, is this your, oh, this is very cool. One second. Let's check this out. Nice. This is your video, right? For the... Love it, dude. It's very fluid, actually. Is this you, by the way, Sensation?
No.
Oh, man. And this was the little county festival you had, right?
Yeah.
Nice. Oh, they have the awards? Yeah, cool. How did you do the transitions? Is it all just like auto transitions?
Manually.
Oh, you manually did this. Oh, nice. Yeah, with all the panning and stuff. Okay, good.
Yeah, I did it by hand.
Shelter box, cool. Thirsk and Sorby Festival on the Flats. Y'all spell flats with 2 T's? Why?
Someone's name.
Oh, okay. That's his name.
It's
Okay,
called
very
Flats
cool.
Field.
Flats Field. Ah, I see. To me, like, flats would be like, we're on the flats. Yeah. Are those British people? They look so lifelike. That's what Jeff's saying. Are those British people? They look so lifelike.
Yes, that's what people look like when they're not genetically corrupted.
Wow. Ash says, I saw your twin in Costco today. Ooh, where? Pick. Gotta send me. All right, let me see what we got for homework question help stuff today. Let's see. Help screenshots. First one comes from Shanktrix. That's good. Oh, you know what? This is actually from my physics class, Shanktrix. Yeah, this is kind of a cool one. All right, cool. What's up, Nick? Good to see you. Okay. Oh, and then let me make sure my TikTok chat is working. Well, I'll just leave it. Whatever. I think I could add it, actually. It gets, like, upset at me sometimes. Okay, cool. Maybe it is working. Okay. Oh, I gotta fit the puzzle? Stop that. Okay, cool.
That's interesting. A bot came in, tried to send something, and then it was banned, despite the fact it's an image.
Oh. Where? Into what? Into YouTube or what?
On Discord.
Oh, on Discord. Oh, okay.
Maybe I put them in detention preemptively because I knew they were a bot.
Well, that's a good thing of you. Okay, let's see. Maria says, hey, I just want to pop and say thank you for helping with my math homework. You saved my report card. Aw, thank you, Maria. That's what I do love. Most of the people that follow us on TikTok found us from some sort of, like, help video that I did, like, one little, like, quick tutorial. So, yeah, I always love hearing that. Thank you, Maria. I really appreciate that. Yeah, she says, no, thank you. Sweet. Okay, we're going to help us out. Shantrix here with a physics question. So yeah, Maria, also, like, if you're ever needing, like, free help and tutoring and stuff, you can always come by these live streams and ask questions. We help you out as well.
No, not TikTok.
I love TikTok, dude. TikTok is so good for, like, reaching the youth. I will say TikTok, their algorithm is top notch at knowing exactly what math or science concept that a student is going through and then delivering them my video. Yes, okay, awesome, yeah. Maria. Yeah.
Good job.
I teach a lot of physics, Maria. So yeah, please. Okay.
It's good at the good stuff and very very bad at the bad stuff.
Yeah, I know. Well, you know, you got to fight fire with fire sometimes, right? All right, Shanktrick says, here's the position of a shopper trying to cop one of the new mini pastel totes at Trader Joe's. This was a thing, actually. There are these ridiculous, like, shopping bags that people were waiting hours in line to try to get, and then they were, like, selling them on eBay for tons of money. But anyways, this is a position versus time graph. And the first question here is, where is the shopper experiencing positive acceleration? Okay, very interesting. So we have to, like, remember some definitions on, these are kinematics concepts. So you have things such as, like, position. Okay. And that's equal to x. And then you have things like velocity, which is the rate of change of position with respect to time. So another way we write this is like dx dt. Or you could say like delta x, delta t. Or you could say it's the slope of a position graph. Okay. And then you have acceleration. Oh, and I should say like what the letter is for velocity. Sorry. Velocity is dx dt, but it's also referred to as just like v a lot of times. And then acceleration is a, which is the same thing as dv dt. So the derivative of velocity with respect to time. The same thing as this. And you could say like the slope of a velocity graph. Why is it ABDC? It's random. Oh, are you talking about this? Why is this ABDC? Oh, that's a good point, actually. I don't know. I didn't draw this graph. I think I just like wrote the question for it, but... You would have said D? Yeah. Well, I believe D is the correct answer. We're going to go over why that is. So if acceleration is the slope of velocity, but velocity is the slope of position, then technically acceleration is what we call like the curvature or the concavity of position, which is also referred to as like the second derivative. So if A is equal to dv dt and V is equal to dx dt, then A is also equal to like d squared x dt squared. And this is referred to as the curvature or concavity of a position versus time graph. Good. A is constant, B is at rest, D is acceleration, C is deceleration. Yeah, I agree with those two things, or those four things you said. So, yeah, there are some key things here. So let's remember that the slope of a position versus time graph is the velocity. So if you wanted to talk about the velocity of this, right, the slope here is positive. So this means that velocity is positive. So you have like positive velocity. Here the slope is 0. So this means velocity is equal to 0. And then here, the slope is still positive, but the slope is changing, right? So what I like to say is like, okay, well, V is like positive here, but then it's like really positive here, and then it goes back to being like not so positive, and then it goes back to being 0, right? So this velocity is like changing. The meters and seconds threw me off because I thought it was a speed graph, and I thought all of them except B are increasing speed. Yeah, this is position. Yeah. Because if you were to do, for instance, if this is Y and this is X, so slope, right, is like Y2 minus Y1 over X2 minus X1. This would be like meters would be your units, and then your x-axis difference would be seconds. Okay, so in meters per second is a velocity, so that's why the slope of position is velocity. Well, just another reason. There's many reasons why the slope is velocity, but like that's just another like contributing factor to it. Yeah. Now, if you look at the concavity is cool. What's up, Sensation?
Hang on. Sorry, I think there's an error with the YouTube chat again.
Oh no! Oh, let me go get it. Sorry.
Stuff's not coming up.
Is it not? Oh, there it is. Yeah, it's screwed up. Yeah, got it. It all just got in. Yeah, it lags sometimes. What's up, Roman? Yes, sorry. Yeah. Yeah. If you ask Sensation will make sure your chat should be showing up now. Yeah. It's all the wonders of technology. I'm trying to run like 3 different streaming services at once, and sometimes the aggregate thing that puts them together, it doesn't refresh it fast enough.
If it all goes wrong, you ask me.
Yeah. You're using distance versus... Okay, so distance is tricky, though, right? You don't want to really say distance, because there's a difference between distance and displacement. You really just want to say position, right? So the reason why you don't want this to be like distance is because like distance has to be referenced to something. For instance, if you go 5 meters this way and then you come back 3 meters this way, okay, technically you traveled a distance of 8 meters, but your displacement would only be equal to 2 meters. Displacement only cares about like the start and the finish, whereas distance is kind of like the total travel path that you take. This actually like kind of goes back to, if you really want to get into it, it goes into like even the path integrals we were dealing with and potentials. So yeah. So that's why we tend to say position instead. Distance is tricky. Distance, you don't want to say distance. It's like a technicality thing. But okay, but with acceleration, okay, so you can have positive acceleration, which on a position versus time graph will look something like this. It'll be concave up. So it's either going to be this side of the concavity or it'll be this side of the concavity. So if you look here, yeah, distance is route length. Yeah, the length of your route. Yes. If you look here, for instance, right, this is kind of like the right-hand part of the smiley face. So this is concave up, which is positive acceleration. This would also be concave up. If you have the thing doing this, this is also positive acceleration. You saw my video about the happy face and the sad face? I'm glad you saw it, Sib. Yeah, that's a really funny one, isn't it? Yeah. So, yeah, happy face. We like happy faces. Positive acceleration. Versus if you ever see negative concavity, so that's going to be like, let's do like negative acceleration. That's when you have the sad face going on. So like just now you know it. Sweet. Yeah, they're always like these little like tricks that you can kind of like pick up. And again, they're ones that I've like seen a lot while teaching, so I try to teach more people about them. But yeah, this is negative acceleration. Say negative concavity. So here, for instance, right? This is like the left side of the sad face.
You done messed up, Aaron!
So this ends up having negative acceleration. Or as I think Monkey Man said, he said deceleration. Deceleration is kind of a finicky thing, okay? Because you can have negative acceleration if something is speeding up to the left. And that gets kind of weird to think about, right? Because usually decelerating means something is dropping velocity or really dropping speed. Whereas if something has a negative velocity and it's getting more negative, the speed is increasing, but the velocity is decreasing. And because velocity is decreasing, technically that's negative acceleration. Yeah, deceleration is kind of, I think it's a finicky. I don't like using it in physics. I think I like just saying positive or negative acceleration. Deceleration can be kind of weird. But yeah, it's all relative. Yeah, it really is, man. So, also, if you were to look at what the instantaneous slope was right here at different points, you see here how like the slope is like kind of like basically 0. Now the slope's a little bit more positive. Slope's a little bit more positive, like as we go to like different positions here. And then when you're here, now the slope is totally like as positive it's going to get. And then it starts to decrease again. So that's an indication of like you have velocity that starts out at 0, it goes up to some maximum value, and then it starts going back down to 0. If you wanted to graph, and this is a thing that comes up a lot in physics classes, they'll tell you to take a position graph and then, for instance, graph what the acceleration would be or what the velocity would be. So if we did velocity versus time here, right? Velocity would start out at 0. It would then increase to some maximum value here. We assume linearly. And then it would then decrease back down to 0. So this would be a velocity versus time graph. And if you wanted to show what it was in terms of acceleration versus time, let's say it's acceleration versus time. Acceleration is the slope of velocity. So this ends up being just like a big positive line here. And then it has a discontinuity where it immediately goes to negative at this point. Yeah. Monkeyman says I usually grab the slope at the top 2 points of the curve. Yeah. In general, when the strat for kind of graphing these is to look at what I call like critical time points, and it's when things are changing. So for instance, when your velocity is going from 0 to like being very positive, these are like 2 points I would consider. I don't really care about what's happening in between. I just know the velocity is going from 0 to something that's really positive. And then from here to here, again, it's like really positive velocity to 0. I don't really care exactly what's happening in between, because you can just like interpolate between the 2 points. Yeah. So yeah, positive acceleration, that's just at part D here, because that's where you have the happy face. And that's how you do that one. Nice. Good question, Shantrix.
Well done! Well done!
Yes, yeah. Acceleration. Are you spelling acceleration weirdly for me there? Acceleration? Let me turn my music up a little bit. There you go. Sipping tea. Teacup. Okay, let's see. Taylor has another question about the ranks of matrices. Mobile. Yeah, I get you. And then Sib, I think I saw you submitted one. Yes. Ooh, wow. We're going to do more surface integrals? That's fun.
I don't think
Nice.
the more apt metaphor for people using mobile phones over like laptops and desktop computers.
What about it? I think it depends on the generation, right? I think our generation still does important things on like a laptop, but I think younger generations do everything on a phone.
Well, no, because I mean it's still objectively shit technology.
Well, it's getting better. I will say that the mobile sites have gotten a lot better. It used to be you had to force the browser to pretend it was a desktop, right? To get anything to actually function. But nowadays it's a lot better. What is the length of my queue right now? Let me see. I got this. I got Sibs. I got Reckies. So I got like three questions. So including this one, just 3 questions, Roman, by the way. Find the rank of a matrix. Yeah, how do you rank matrices? It's like, well, which matrice gets first place? Which one gets second place? Okay, rank. I think rank is the number of like non-zero rows. Is that what it is? I want to say that's how you find the rank of a matrix. I think. What's up, Damien? I think to find rank, you first have to put it into row reduced echelon form. So you have to try to get this thing to look as simple as it can. And then I think you count the number of non-zero rows. Oh, you're new? This video is what I've been looking for, TBH? Okay, cool. Are you talking about... Well, this is a stream. This isn't really a video. But if you're looking for a stream to help you out math and science homework, we do it like 3 times a week here.
Why do I get this distinct impression that this person is so stupid they'd fail a blood test?
How do you fail a blood test, Sensation? What? I actually like kind of like failed a blood test. I went to go donate blood. I was here on stream with you guys after that happened. Does anyone remember the stream where I started like blacking out? Like I couldn't see things. I remember like it was like I was like 2 or 3 hours into the stream and I was like, guys, I can't see my screens anymore. Like I'm getting like hypoglycemic right now. I need to like stop the stream. It happened a couple months ago. You're okay, Damien.
Yeah. Always eat the cookie.
Always, yeah, I did eat the cookie, but like I don't know, they tricked me. I was at the gym, I was working out, and then as I was leaving the gym, they're like, "Oh, hey, you want to donate blood?" I'm like, "Well, I kind of just finished at the gym." They're like, "Oh, you'll be okay." I said, "All right, fine." It definitely wasn't. wasn't okay at all, dude. That sucked. I almost fainted. I went pale. And then I got home and ate so much sugar to try and like get my blood sugar back up, and I guess it ran out during the stream because I remember just being like, I can't see anything. And then I still had to go teach.
I don't know if I ever mentioned that. After the festival was over, not the Sunday just gone, but the one previously. The first day just had to scrape me up off the ground.
Oh no! Why'd they have to scrape you off the ground?
I just
You're going a little
fucking passed out.
Yeah, you're getting a little too turnt at the festival.
I was under the sun for 3 days, and then when they tested my blood sugar, it was like through the floor.
Oh no! Oh no!
So heat stroke and hypoglycemia.
That's no fun. No fun. Let me see what's happening here. Oh, actually, I think I know how this works. Yeah, watch this. Okay. Shantrick says, I learned yesterday that there are 48 human blood types, and they are so unique that they are named after the person who had the unique blood type. That's cool. Okay. Find the rank. So, in order to... I guess there's a couple methods of how to do... Finding the rank is finding how many linearly independent equations you have within a matrix. I think is kind of how we say this. So, for instance, here's some good examples of like rank 2, rank 1, rank 0, right? This thing is rank 0 because within the matrix there's no unique information, right? You have like 0, 0, 0, 0. If you were to say this was like an equation where like x equals like whatever, you would have your x equals 0, y equals 0, and that doesn't really like tell you anything. This matrix is like kind of unique. The only problem is that like this is a direct copy of this one. So for instance, if I were to take this row, okay, and multiply it by -2, let's say multiply it by -2, and then add it to this row, do you see how I would then get 1, 1, and then this would be -2 plus 2, which is 0, -2 plus 2, which is 0. So this would be your new matrix. This is rank 1, because you only have one non-zero row in the matrix. Versus this one, there's no way to like try to multiply this by something and combine it with this to completely cancel the entire row out. So here, for instance, you have, this is kind of a null matrix. There's nothing interesting here. This only has one row that is interesting because because the second row is just a multiple of the first one. So it doesn't really give us any new information. And then, yeah, this one. What is this used for? You've never seen this before? Rank of a matrix. So if you're describing like linear equations, it can also give you what's called like the dimension of the solution space, which is, for instance, like how many solutions there are. So in here you have like 2 solutions. Here you only have 1. Here you have 0 solutions. Like if this was an augmented matrix, right? This tells me, for instance, like x equals 1 or x equals 2. There is no solution there. You can't have x equal 1 and also equal 2. So, in this, for instance, you have, okay, 1x equals 1 and 2x equals 2. That is a single solution. The solution there is x equals 1. For the third instance, yeah, you have like 0x equals 0, 0x equals 0. Yeah, I guess x could be whatever you want, technically. Yeah. I think the dimension, though, can only go up to the size of the matrix anyways, though. So I think it tops out at 2. You are right that there are infinitely many solutions for this one. I'm trying to, like, tie it back to when you do systems of equations as an augmented matrix, the rank of that augmented matrix has to be at least the number of missing variables you have. Otherwise you don't have enough linearly independent equations to describe a system. So this is, I mean, technically what they say. They say rank is equal to 2 minus the dimension of the solution space. I wonder if that is because it's is that because it's a 2 by 2? Let's look that up, actually. Sorry. Dimension space. It doesn't have to be a square matrix. No. You can determine the ranks of these, for instance. Watch. Let me pull them up. I just want something like real quick. Unless someone else knows this off the top of their head. What's up, Equity? It definitely does not need to be square. It doesn't have to be a square matrix to figure out the rank. Drink. Thank you, Sensation. What's up, Dr. G? I got a physics C test on Thursday. There was one question on our homework I couldn't understand. I'm going to submit that. Do it, Anish. I'll help you out. Yeah, let's do it. And then Monkey Man says, it's midnight 41. I got to finish a Python project. Yeah, good night. Yeah, come by the chess tournament on Saturday. Make sure you know what time it is in your time. Ooh. Very cool. So, let me think. So there are limits on rank, by the way. Let me wrap this question up for Taylor. Rank can only go up to the dimensions, the number of rows that are in the matrix. So if there are 2 rows, you can have only up to like rank 2. You can have from rank 0 all the way up to the number of rows you have. So in this case, for instance, this could be a maximum of rank 2, but you need to make sure that this isn't a copy of this one, which it is. Do you see how if I take this and I multiply it by -3, that I would get the same thing, right? 2 times -3 would get me -6. -3 times -3 would get me 9. So because this one is a copy of this one, this is essentially 2, 3, and then we would say like 0, 0. So this is only rank 1. Also, if a third one is like a linear combination of the other 2, then it also goes away as well. Which I think this one's okay. I think this is probably rank 3. I don't see any immediate like combos that would work. This one as well, because if I multiply this by 3, I get 3, 2, 6, but then this doesn't become 19. So this one would not cancel out this one completely. And then the other thing we got to check, right, is to see if this plus this like cancels that out, which it doesn't either. 3, 6, yeah, -4. I think this is probably rank 3 as well. Chess tournament's on Saturday. I'm going to make an announcement in our Discord, but it's going to be Saturday at 3 o'clock Pacific time. Yeah, exactly. Yeah. Well, really what you're supposed to do is you're supposed to do RREF. You want to get it into row reduced echelon form, which is you want to get basically like 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. You want to get it to look something like this. And if you have any other ones that are throwaways, you're going to get like 0, 0, 0, 0, 0, 0, 0. In this case, this thing would be rank 3. Because these ones don't count. I'm trying to see if there are any other easy ones here that like I could just eliminate real quick. I don't really think so. Yeah, no, right, yeah. How do you achieve RREF? Well, you can get a calculator to do it for you if you really want to. There's also what's called Gauss-Jordan elimination, which is what Nati Israel is kind of like talking about. You're talking about Jordan form given only the eigenvalues with geometric multiplicity under quaternions in closed ring space, bro. What are you asking on my stream, dog? What? You could also put them into Desmos and see if they're the same slope. Yeah. You mean if you were to write this as like an equation? Maybe. What would that be? That would be like 1x plus 2y minus 2z equals 3. Is that kind of what we're doing? Why can't you answer my questions?
Wait. I have a question for Natty.
What are you going to ask Natty, dude?
Would you like some balsamic vinaigrette with that word salad?
Yeah. I don't... If you want to talk about quaternions, I have a friend that actually does quaternions, but he doesn't stream. That's a lot of stuff there. Yeah. If you wanted to see like real quick how we do it, let me just show you, and then I'll move on to the next question. But let me just show you how you can do RAF on a calculator. There is what's called Gauss-Jordan elimination, which is a process to do this. It just takes forever. But let's look, for instance, at this one. Well, I'm pretty sure this one's rank 3. So if I go to like second matrix, and we go to edit, and I make this a, what is this? This is a 3x4. What do you think of model counting? That's another advanced math thing.
You're like a photon with no frequency. Completely meaningless.
Completely meaningless. -6, 19. Okay, if you do this, so if you put this into your calculator, and then you go like second matrix. Math. Do some RREF on it. Oh, wait. Oh, I don't want to do that. I forgot. You have to... Let's make sure this matrix... Okay, so that's my matrix. Then send second matrix math REF on matrix A. Let's see what we get. Yeah, this is going to be rank 3 then. Because you see how all 3 of these columns, all 3 of these rows, sorry, are unique. So 1, 2, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Yeah, that's rank. That's rank. Rank 3, but I don't think that's solvable. Right? That's kind of weird. If this was a 3 variable systems of equation, you can't have that like this last column here like screws things up. What's my education level? I have a PhD in physics. You know, and actually let's throw this real quick at ChatGPT. I want to see what ChatGPT says. Always love seeing
I'm just
AI
finding.
thing. What are you
I'm just finding new and impressive ways to insult people.
The beatings will continue until morale improves. So you're a noob? What?
Your brains in a superposition are stupid and irrelevant, but no one's observed the useful part yet.
Oh man, these people are funny, dude. All right, cool. It's doing row reduced echelon form. Let's see. Let's see what he gets. It's taking a while. I thought ChatGPT 5 was supposed to be fast. What's this garbage? There we go. So, it also thinks it's rank 3. Cool. Sensation. Anish is asking about your Dragon Ball opinions, apparently.
Bit vague.
Bit vague. Yeah, which Dragon Ball are we talking about? Okay, nice. I hope that helps you out. Good question, Taylor Drew. Also, Taylor Drew, congrats, dude, on getting tier 1 so fast. That was pretty cool. So, I bought Taylor a $10 PlayStation gift card today. Because they asked a lot of questions during the streams last week and did a lot of things in our server. So, if you also want to, like, win gift cards and... Well, not really win. You're not winning shit. You're earning it. If you want to earn gift cards in our server, just join our server. There are the links down below there. But good job, Taylor. Congrats. I actually don't know why it's so slow these days either. I mean, it is a language model, Taylor. So it's not particularly great at doing math. But I mean, it's been getting better. Are you more of a monad or a monoid in the category of endofunctors guy? DeepSeek is great at math. Okay, that's cool. Okay, let me help out.
Isn't DeepSeek the shite Chinese one?
Yeah, it's not shite. I mean, it was like kind of stolen, but that's whatever.
Because it's Chinese, it's shite. That's end of conversation.
Dang. I don't think all Chinese things is like the Chinese do a very good job at copying shit. I'll tell you that. Like I've sourced a lot of things from China. If you give them something and say, "Hey, make this for me," they're really good at doing that. They're really good at like we can just like copy this. I've told them many.
The Hong Kongese were always so much better than the Chinese.
Oh yeah. Well, I mean, it depends like
It's
how good of a job you need for things. Okay. Let's see. What's up, Sib? Sib, do you want help with this one, Sib? Let S be the portion of the sphere. X squared plus Y squared plus Z squared is equal to 16. Okay, so this is a sphere radius 4, right? All right, let's do it, Sib. Sphere radius 4. Where they say X squared plus Y squared is between 4 and 8. And Z is greater than 0. Okay. So this to me kind of seems oh man, what is this? Is it I mean this looks like a circle, right? A circle that is between radiuses 2 and 2 square root of 2. I think we are going to use spherical coordinates, right? Yeah. And then they want us to integrate 1 over z ds, so on the surface. So I think this is what like the shape looks like to me. I think you have a sphere, right, of radius 4, and then we're specifically looking. Here, let me draw some like some lines and stuff.
Dude's like, stop ignoring me. Stop being a bellend then.
Don't make Sensation mad, Naughty. He'll ban you. He has mod powers in my chats.
I
okay.
Mod powers on the internet, and I'll just go to his house and tell him.
Yeah.
You done messed up, AA Ron!
Okay, so if x squared plus y squared has to be between 4 and 8, I believe. And also, so z is greater than 0. So that means we're only looking at the top half of the sphere. X squared plus y squared is equal to 4. That defines a circle of radius 2 in the xy plane. So I think what we're doing is we're going from like here. So this would be like, for instance, radius 2. Radius is equal to, right, 2. And I think we're going up to where the radius is. Oh, wait, sorry. Radius equals 2 is going to be, sorry, I have this wrong. This would be 2 square root of 2. This would be radius is equal to 2, right? And then I think we're doing all of this. It's like a little Death Star. Why did I draw the vertical circle? Oh, just to make it look like a sphere. I'm just trying to make it look like a 3D sphere. I mean, we don't need that if we don't want it. It's okay. Yeah, so this is a sphere where I believe we're looking at just the surface of, like, you can think like a ring on the top of it. I don't know, kind of looks like R2-D2 or something. You know what I'm talking about? R2-D2. Yeah. I'm a huge Star Wars fan, if anyone didn't know that already. I love Star Wars. It's a truncated R2-D2, yeah. So, yeah, exactly, yeah. So, think about R2, right? We're only looking at, like, the top half of R2, right? Because Z has to be greater than 0. Right, from this, Z is greater than 0. And then x squared plus y squared. So if this is x and then this is y, then you're only looking at circles in the xy plane that have radius 2 up to radius 2 square root of 2. And so the radius is 2, like kind of at the top of the circle, top of the sphere, right? This is where you have like probably like the smaller circle. And then a little bit more in like the meat of the sphere. That's where the circle has a radius of 2 square root of 2. You're actually interested, Nati? Okay, if you're actually interested, here. There's my thesis. Enjoy. A spherical frustrum is the official name. Oh, that's cool. Okay. So, yeah, so we need to parameterize the surface, I guess. Because it would be hard to write this in terms of just x, y, and z, I guess. Yeah. You want to try to do the integral in terms of as low amount of variables as you need in order to describe this. So the cool thing is, if I want to describe something in 3D space with a sphere, so r and theta will tell me, right, angularly where I am around the sphere, and then radially, how far out I am. And z can then actually be connected to r and theta as well by this. Yeah. There you go. You got it. Not Los Angeles Police Department. It's the Large Axial Plasma Device. Okay. So, anytime you have a sphere, I mean, a handy parameterization that comes in is x is equal to r cosine theta, and then y is equal to r sine theta. Okay? This is just very useful to parameterize. So, if I want to parameterize my surface, S, in terms of like some coordinate, right, x, comma, y, comma, z, I can now say that x is equal to r cosine theta, y is equal to r sine theta, and then we got to come up with something for how z connects. The key to that comes from this. So I can write z in terms of r and theta using my things for x and y. Okay, so x is equal to, if x is equal to r cosine squared, r cosine, so here's actually a really cool thing. If x equals r cosine theta and y equals r sine theta, then x squared plus y squared is equal to r squared cosine squared theta plus r squared sine squared theta, which is equal to r squared cosine squared theta plus sine squared theta. And cosine squared plus sine squared theta is 1.
Oh, yeah.
So x squared plus y squared is just r squared. So now what you can do here, Sib, is instead of saying this is x squared plus y squared, you can replace this with just r squared. Okay? So now you have r squared plus z squared is equal to 16, or that z is equal to the square root of 16 minus r squared. So that's where they come up with this. They say, okay, now we've reparameterized x, y, and z in terms of only 2 parameters, r and theta. And from here, right, x squared plus y squared, wow, this is already r squared. So I know r is then between 2 and 2 square root of 2. Theta is going to be between 0 and 2 pi, because you're going to go all the way around the sphere. Okay? And then now this is the function for your surface. Okay. All right, let me think here. Okay, so once your surface has been defined, right, by two parameters, you can then get the two tangent vectors, right? So this is TR and T theta. And the way you get TR is you do DG dr. Or really do this. You do nabla RG. Because it needs to be a vector. So the derivative of this with respect to R becomes cosine theta, sine theta, and then this is a chain rule. And then this is a vector because this points in the x hat direction, this points in the y hat direction, this points in the z hat direction. And then if you want to do nabla theta of g, then you take derivative of this with respect to theta. And so derivative of cosine is negative sine, derivative of sine is cosine. This doesn't have theta in it, so that just becomes 0. It's actually kind of really nice. Okay. And then to get your normal vector, you then do TR cross T theta. Okay. And so that we did in an earlier lesson. I think we did that over here. Where did we do it? It is like yesterday's a bit. Exactly, yeah. Well, no, this was it yesterday's? Oh, it was this. Yeah, exactly. Yeah, it's a matrix, yeah. So you do this. This is how you do the two tangent vectors cross with each other. And then cool. So then they find the magnitude of it. Okay. So okay. How do we get to this step though? Because isn't there another Z in there now? Oh, okay. Okay, so in this case, right, Z. This is vector calculus. So Z was equal to the square root of 16 minus r squared. And then I think when we do the ds integral, we're going to do this is going to be like 1 over z. ds I think is going to be equal to just n. I think you're just integrating n. I think it's like n, and then it's like dot what your parameters are, which is like dr d theta. So let me see. And is it magnitude of n? I guess it is, because look, they have this 4r over the square root of 16 minus r squared. And then you have 1 over this being multiplied, so that's why this square root goes away. And then you've already set your bounds for dr and d theta, right? R went from 2 to 2 squared root of 2. Theta went from 0 to 2 pi. And then this is just u sub. This is a u substitution integral. Well, actually, sorry, it's just ln, actually. Well, yeah, u sub, but ln, yeah. You saw this during your freshman year? Okay. Yeah, what chapter is this in, Sib? What is this exactly in this chapter? What's it in? I'm curious. Oh, you're very welcome, Sib.
What's IB maths?
IB is International Baccalaureate. IB stands, that's what the AP exam thing is for like international students. AP is mainly a US based thing. IB is like the international equivalent.
I've heard of baccalaureates, but they tend to be English.
Yeah.
And the arts.
Yeah. No, I think IB, AB is all kind of the same stuff. Okay. Yeah. Nice. I'm curious where this came from. This DS, is it really just abs? Is it this really N R theta and then dr d theta? Is that how that works? Kushquant, I see your question. Are you commenting on this one? Oh God. Yeah, more practice. Okay, it's the midterm 2 again. It's supposed to include Green's theorems, line integrals, Stokes theorem. Okay, let me see if this is Stokes. I can't remember what like Stokes theorem is. Oh. Okay.
What is Stokes' theorem? I don't know, something about vampires.
Yeah, Stokes' theorem has to do with like a contour integral is equal to the double integral, and then yeah, I see this Rx cross Ry. I think I want Green's. I think it's a Green's theorem question. Yes, it is. Yeah, definitely upper division E and M. You will definitely do this in upper division E and M. Yeah, okay, this isn't Green's theorem, though, because Green's theorem does the weird partials. That's what we did earlier. Green's theorem was the cross product. Well, this is like magnetic field stuff. Here, I think this is what I want. Here are all the theorems. Yeah.
I can't even read that. It's just...
What's equity saying? Which statement helps to explain why ice is less dense than water? It's always hydrogen bonds. Anytime they ask anything about water, you just say it's hydrogen bonds. Like my late chemistry professor used to always say that. He just said anytime you see anything about asking about unique properties of water, just say hydrogen bonds. What math is this? This was vector calculus. Here, I'm gonna go help out. Good question, Sid, by the way. Let me go help Anish. You've been waiting for a little bit. I don't think you've asked a question in my stream in a while. Where did Anish submit theirs, though? Do you remember? Or was it in the chat? Anish, where'd you put it? Yes, Kushkwan, I'll get to it. Yeah, we have a little bit of a queue today.
Be patient, Chaiwala.
Wait, where did Anish's question go? I could have sworn I saw it. Anish, where'd you go? Or maybe it got deleted. Oh, Anish did delete it. Oh, okay. Honest, if you still need help, let me know. Okay. Sound a little loud. Okay. Let me see. That was Sibs. Next, Recky's, and then Kushkwan. I'll look at yours. Okay, you're good. You're good, Anish. Just let me know when you come back. I'll do yours.
Maybe I should switch from swearing at everyone in Hindi. Well, that wasn't swearing particularly, but I should switch to just swearing at people in Japanese because I know that more with greater clarity.
How do you know how to swear in Hindi, dude? What?
Well, all the scammers come out of northern India, so you just learn these things.
There you go.
Bazrige mata chod.
There you go. Anna says, I'm here. I made a yogurt bowl. Oh, dope. Well, send me your question, Anish, when you have it. I don't see it. I think you deleted it, so repost it if you want me to go over it again. Let's help out Reki. Determine the amplitude of each function, then use language of transformations to describe how each graph is related to.
Oh, poor Anish probably thinks I'm talking to him now.
Okay. Amplitude. Amplitude's always just the number in front. Reki. Yeah. Nice. Okay. Okay, honest. I do see it. Amplitude's just always this number. Okay. So yeah, if you have like a sine wave and it looks like this, let's say this is like amplitude equals 1, then this, for instance, would be like, I don't know, like amplitude equals like 3 or 2 probably. It is the absolute value of that number. That is true. Yeah, and the only thing when it's negative, this just means it flips over the x-axis. That's all the negative means. Here, let me do this one now. What's up, Famished? Interesting. This looks like Kudu. Is this from Kudu, by the way, Anish? I recognize the font. Is this from an AP Physics C course I gave out or something? Maybe. Reki, ask me a better question, dude. That's a really easy question, Reki. What? Reki, the whole point about asking questions should be something that you want to learn, not something that you like already know, or that I could answer in like 10 seconds. Ah, it's Physics 1C with tongue. Oh, so this is 100%. This is Kudu then. Yeah. Okay, here we go. A non-conducting hard rubber circular disc is painted with a uniform surface charge density. It is rotated about its axis with angular speed omega. Find the numerical value for the magnetic field when that's that. Oh, okay. So, magnetic field is related to change in, find the change in current? I think you need like current or something. One sec. I think I need to remember how this works. It's no, wait. Universal surface charge density means you're gonna have an electric field, and then it's rotating. And does that electric field cause a current? It's non-conducting though. I need to look at Maxwell's laws. Maxwell's equations.
A conducting material on the top of a non-conducting surface.
It's one of these.
Static magnetic field.
Okay, Reki, cool. It's not B.dA. Is it E.ds? Or is it this one? Ooh. I think it's this one, maybe. Is it this last one? Is it changing electric flux? It might be. All right. Because this is spinning around, okay? And as it spins around, you have electric field that's being... Oh, wait, one second. TikTok's getting mad at me. There we go. It's Ampere's law. Let's see. Consider the disk as a current loop? Oh. Oh. Okay. Yeah, okay. Because, yeah, Ampere's law is this one. One second. Ampere's law. B dot dl is mu naught I. Yeah. Okay. And then I is equal to, like, dq dt. Right? Oh, very cool, famished. I don't think I want to do it with displacement current. Oh, summer children. This is a very, like, I like this thing here. Okay. Yeah, because here's what they're saying, is that if you have something with charge on it, let's say, for instance, you just had, like, a single charge Q, okay? And you made this thing go around in a circle, okay? That would give rise to current. Because current is equal to dq dt. And so if you're taking a charge Q and you're moving it around at a certain rate, then that is, you're basically, like, forcing there to be, like, current. And that current, which is being enclosed, will create a magnetic field of, yeah, this is the B dot dl thing. Well, usually what happens is you have a straight line. Yeah, usually you have a straight line of current going this way, and then that generates a magnetic field here. This, we have, like, a loop. It's very weird because you have a disk and it's rotated about its axis. Okay. So here's how I kind of think of this. Let me try to draw pictures. You can think about that, every little, like, piece of charge here that, like, moves around in a circle is a current. And that current is going to generate a magnetic field. So if you have current going around this way, that generates magnetic field going up. And then you have to, like, integrate it over the whole rotation space. Oh my god. Oh no. Yeah, you need to find the current for the entire disk. Okay. Well, Q. Let's just write some things down. I was like, let's just write some things down. Q is equal to sigma A. Chegg is sometimes wrong, dude. Okay, so Q. Q is equal to sigma A, right? Which in this case is going to be equal to sigma pi r squared. Okay. And then dq dt, which can be thought of as like how much of that charge is moving per unit time, that's going to be related to omega. So, yeah, if you were to model this as... Yeah, I think dq dt is equal to omega times q. Because omega is how much it's rotating. Or is it 2 pi omega? Because that's a frequency, right? So omega is equal to like 2 pi f. So omega over 2 pi is equal to f. That's equal to 1 over seconds, right? So dq dt should be equal to like q per second. So I believe this is going to be equal to sigma pi r squared, because that's the total charge you have. And then you're going to multiply that by omega over 2 pi, because that's the frequency at which that one little bit of charge is moving. Like doing one revolution, right? A single bit of Q here does a full revolution in omega over 2 pi. And then this would get you Q over S. Okay. But now, yeah, do you have to integrate? Because your b.dl that you're measuring here, like, gets out like further and further as you go further and further out. Oh man. I think there's like some symmetry arguments where you just like argue all of this just becomes like a straight line that's going around. This is physics E&M. Yeah, this is physics E&M. Let me see. You know, the other funny thing is, I actually probably have access to this question. Let me go find it real quick for you. This is in the Ampere's Law chapter. This felt like a flashbang. Everything else was quick, plug and chug. Ampere, Bios of Art, yeah. The reason why this is tricky, man, is that, again, like, things that are spinning, yes, do create current, because you have charge on this plate that's moving around in a circle. So it's simulating there being a current I. The issue is that when you do Ampere's Law with B.dl, now the circle that encloses that charge moving around, like, starts changing as you start integrating over the circle. How to be good in organic chemistry? Practice. We're just a lot of memorizing, honestly. Let me find this. Physics 1C, right? Yeah, okay. And then this is... I want to say sources of magnetic field. What's the name of the chapter, Anish, if you can tell me? I think I found it, though. I think I found the chapter. Yeah, cool. Sources? All right. Yeah. I have access to all the courses. Let me see. Ooh. So here, I have it for not random numbers. So let's see if we can reverse engineer it. This is what the answer would be if we weren't. I hate what they did with ChatGPT 5. I think it's garbage. I think it's so bad. I really don't like what they did with ChatGPT 5. Oh! Oh, there's something cool here. So here, Anish. You see how it says height is equal to here? They want the magnetic field, because I was wondering, I was like, wait. Where do you want the magnetic field? They only want the magnetic field for a certain height. Which is kind of nice, I guess. No, I'm still working on this one, Reki. Sorry. I just want to think about it. Let me see. One sec. Spinning disk of charge magnetic field. Well, here we go. There's a video on it. Physics Ninja. What's up, Physics Ninja? Jesus, why is it a 22-minute video, dude? What?
We're going to look at how do you calculate the magnetic field that gets produced if I take a disk that has a total charge Q. Assume that this is an insulating disk and the charge is uniformly...
Okay, let's see how he does this. Okay. Yes, so the magnetic field from a ring of charge, you've probably done this from Biosavar, right? And you only want, yes, you only want the X component. Oh, interesting. I have my picture drawn completely wrong, Anish. Okay. Because, okay, it said it was rotated about its axis. Okay, I think I get this more. Okay. I thought it was flipping this way. It's not. You know, I thought it was like a coin. You know, like a coin? Like you flip a coin, like you spin a coin like on a table. Turns out it's this. I guess this does make more sense on its axis. Okay, cool. Oh, okay. So, you've probably done, right, what the magnetic field is due to a ring of current, right? I was getting kind of close with this, but my setup was wrong. So, that we learned from... Yeah, there's all this stuff, but... Yeah, where is it? It's here. Field at center. Equity, can you send me screenshots instead of, like, I can't see that text. Like, you can't just dump text in the chat, dog. Okay. This is what we want. So actually, you don't need this. Well, it's still uploading. Okay. Okay, so it turns out the magnetic field that's located on this axis for you having a current running around a circle is equal to this. Okay? And then what I want to imagine is that my solid sphere, my solid disk of charge, it rotating around, that charge is moving around in a circle. That's going to create a bunch of, like, little wires that are loops of current and contribute to this. So I think I can use this. But then we need to integrate, like, outwards, like DR. Okay, so if... What are you trying to solve, Braden? Oh, here you go. There you go. There's the question if you want to see what we're trying to solve. Okay, so, dBz is equal to mu naught I dl over 4 pi, and then that's r over z squared plus r squared to the 3/2. In this case, this is going to end up being our z, because that's how, like, far above the disk we're measuring the magnetic field. And then I think for I is equal to dq dt, which is going to be equal to sigma. It's like 2 pi r sigma dr times omega. I think is what that is. Maybe I didn't need the 2 pi in there. No, I don't need the 2 pi, sorry. Yes. Oh. You know where this comes from, actually? Okay, watch this. So V is equal to R omega, right? So this right here is like V. This right here is like dq. Right? So dq dt is the same thing as V dq. Where V here, right, is like ddt. Okay. So I think that or it's really, I think it's is going to be equal to, or it's di, right? Okay. Di is equal to r omega sigma dr. This gives you how fast the charge is moving. This gives you how much charge there is on the disk. And then di is then like the little bit of current that you're integrating here. How the fuck to do trigonometry combined with geometry? You need help? Well, if you have a specific question, send a screenshot. I'll go over it on the stream here. There's a link down below. Okay. So, I think instead of IDL, I'm just going to say I think IDL is going to be equal to LDI. Oh, well, so, poll, take a screenshot. Screenshots are the best thing. If you take a screenshot and you submit a screenshot of like what the question is, then I can pull it in. I can't look up where the Israel Final Math Exam 2025 summer is. I don't know where that is. I don't live in Israel. Okay, this is 2 pi r. Alright, let's use little r, sorry. 2 pi, or let's use big R, fine. 2 pi r. Oh, okay. Well, then send a couple screenshots. No, it's not. It's unfortunately not. If you want to see what the final answer is, this is what we're eventually trying to get to. Maybe Nick. I don't know. I'm kind of running out of time today. This is eventually what we need to get to. So then is it r squared omega phi dr? It's above the disk. It's above the disk. Braden, yeah, we want the magnetic field above the disk. So I think you have mu naught I, or IDL is now 2 pi r squared omega phi dr. But then this is r to the third. And this is over 4 pi z squared plus r squared to the 3/2. And then I think we're integrating this from 0 to r. Let me see if that comes out okay. So this cancels. I get mu naught this omega over 2 r to the third over, yes, okay, z squared plus r squared to the 3/2. Uh-huh. dr. Integral from 0 to r. Okay. And then this is a messy integral to do. Yeah, Jesus Christ. How do you do this integral? Is it integration by parts, maybe? It's Hebrew. I don't speak Jewish. I know how to say what is it? Hefsi v'hefsi, right? Half and half. So. Tada. Okay, Honest, are you still with me here? This is the final result you need to get. I do not know how to easily do this integral. Jesus Christ, how do you do this integral? What? Yeah, no. I lied. I don't think that works. Yeah, well, the issue is doing this integral. Like, yeah, sure, a lot of them are constants, but integrating r to the third over z squared plus r squared to the 3/2. This is a mess. Because this isn't a simple u sub. Okay, thank you. Like here, if you want to see like how ChatGPT does this integral. It's kind of a mess. Like, this sucks. I don't want to do this. I guess you say u is equal to r squared plus h squared. dr is 2r dr. So that's r squared r dr. Oh, that is clever, actually. Yeah, that's clever. Then this becomes u minus h. Oh, okay. No, but dude, this sucks. Okay. No, this is a physics class, actually, is what this is. Yeah, this is a college-level physics class doing E and M. No. Dude, there's no way you would need to do this integral. This is trash. I don't think so. I don't think Nathan's that mean. He's gonna make you do all this. It's a physics question. But I think this should come out correct. Have you tried doing this? Doing this equation for this? More UCLA summer physics. So no, this is the course I would have maybe had to teach, but I turned down. I turned down teaching this course because I have to go to Burning Man next week, and like I would be so burnt out, no pun intended, from like doing more teaching after that 6-week bender of a course I taught earlier. The vid you sent, where'd you send it? Where'd you send me the vid? Did you send me a screenshot, Equity? Send me a screenshot. You can't just like send me stuff in chat. My chat is like wrecked with things. Oh, you did send me stuff. 13 and 20. Yeah, I see it. You're good. Oh, YouTube blocked it? Oh, that's whack. Yeah. So, where was it? This has the solution for it. This is a pretty good solution. It's 22 minutes long. And, you know, I don't really want to go through 22 minutes of this. But, yeah, this is pretty much what it is. Yeah. DQ is lambda dA, which is sigma 2 pi r prime dr. But, yeah, they get the same expression here. So, here, Anish. Go through this. It should get you the right answer. You did send me a screenshot, although I will say it's very blurry. It's right. You sent me this. I can't really read Hebrew, but it's also blurry. Oh, actually, no, it's not that bad, actually. Sorry, I can kind of see it. Let me see if I can send this into ChatGPT to translate it. You want question 6, and then Kushkwan, I'll do yours, and then equities. One sec. Let me get ChatGPT translating this. Oh, the formula worked? Nice. Okay. Yeah, watch that YouTube video, Anish. I like kind of half explained it here, how I did it, but that guy's got a 22-minute video, which probably does it pretty well. And then, yeah, the calculus kind of sucks doing this. But, yeah, check it out. Yeah, but, yes, good job. Yeah, giving me a question from the future class. That's exactly what I want. I do want to see that. I want to see what Nathan's teaching. BVM 5 and 4. I thought you said you wanted to do question 6. You're welcome, dude. Let me see what Kushkwan had. One sec. The solid sphere. You guys are asking all the magnetic dynamic questions today. The ratio of the magnitudes of the magnetic dipole moment to the angular momentum. Well, I mean, angular momentum is equal to I omega, right? We know that. That one's not too bad. L just equals I omega, right? Which I think for a sphere is that 2/5 mr squared? Yeah. 2/5 mr squared. Magnetic. I don't know what the magnetic dipole moment is for a for a spinning sphere. All right. Okay, here we go. There's a nice, cute little video. dm is equal to di times a. Okay, I'm gonna leave this as an exercise to the reader for you to go find the magnetic dipole moment if you really want to do it. I'm just gonna take the result. Magnetic dipole moment for a sphere is given as 2/5 q omega r squared. So this is the magnetic dipole moment, which is little m. Okay, cool. So then the ratio of the magnetic dipole moment. I know your question is trig, dude, but there's... Yes, I know Poi Poli, but there is a Q. There's a lot of people that submitted questions before you. Okay, so if I do the rate, well, the 2/5 cancel, right? So what do you get? Q omega r squared. Well, the r... Wait, the omega cancels. This cancels. Oh. So it's just Q over m. No? So in that case, alpha is equal to 2. If you want alpha q over 2m to equal q over m, alpha equals 2. Cushquant. I think that's what it is. Cushquant. Cushquant. It's 1.67? Well, I don't know what to sell you then. The funky gold alpha. Yeah. Explain to me why it is, if you want, Kushwant. I just took what the magnetic dipole moment was for a spinning sphere. Who did this? University of Bonn? Someone wrote up like a whole document on this? Dang. Doing Green's functions. Oh, because it's a, sorry. Sorry, you said it was conducting? Oh, okay. Well, then it's 1/3. Okay. Yeah, okay, sorry. Sorry, I misread that. This is conducting. It's 1/3 over 2/5, which is gonna be 1/3 over 2/5. 5/6? Okay. So 5/6 Q over M is equal to alpha Q over 2M. So alpha is equal to 5/3. Okay, cool. Yeah, that is 1.67. Nice. Yeah, that works out.
Well done! Well done!
Poipo says people should stop learning physics. It's all just formula spams. I mean, at this point it's formula spams because I'm pretty fucking tired and I don't want to like rederive the dipole moment of a sphere. It's not a formula spam. It's a formula spam because I just don't want to rederive it. It's gonna take me like 30 minutes to go do it. And there's a lot of like intuition you have to do with it. Okay. Poi Paul, I will try to do yours. You gave me something and... Aren't you the same guy that's been banned today? No, that was... Well, maybe it was. It was another Israel guy. We do have a lot of people from the Middle East, I guess. Speaking of formula spams, let's do some trig. Yeah, seriously. Okay. Here, I'm gonna try to pull in your question 5. I need to go find. Okay. Yeah, but y'all read this all funny. All funny. Yeah, exactly, Shantrix, right? Formula spams plus spam a bunch of random lines until SOHCAHTOA works. Yeah. Pretty true. Okay. Okay. There is a circle with center M. It intersects the y-axis at a point A. Well, intersects the x-axis at a point A. So it's not really... Okay, well, something's already screwing up. AB is a diameter. Okay, cool. Alright, so I know this is equal to this. Point C lies on the x-axis outside the circle such that it is tangent to the circle at C. What? Such that the tangent to the circle at C is parallel to the y-axis. Well, this doesn't... That doesn't make any sense. Oh, dear. Oh, dear. Oh, dear. The Hebrew is not Hebrewing today, dude. This diagram does not look like what's being described here. Okay, I think this is tangent, is what we're saying. I don't know what thing it's parallel to. The equation of the circle is that find the coordinates of point A, find the coordinates of point B, find the coordinates of point C. You think point B is supposed to be point M? No, 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 no. The circle has a center at M. I agree that this is the center of the circle. That question made me final my finals. Oh. Well, either the translation is screwing up, but like this is not corresponding to what this looks like. I think CB is tangent to AB. I agree with that. I agree. Just like the Hebrew isn't matching up. Okay. Find the coordinates of point A. Well, point A is where y equals 0. So all you have to do is just solve this for y equals 0, right? So you have x minus 2 squared plus 0 minus 6 squared is equal to 100. So x minus 2 squared is equal to 64, right? X minus 2 is equal to plus or minus 8. So x equals 10 or x equals negative 6. And it's probably the 10 one because it's on this side. I agree, Fembox. A is 10, 0. That's not too bad. You see that? Poipoli? Coordinates of B. Well, that's easy. You can use symmetry to find B. Yeah, because you know if this distance is 5, right? That you just need to go another 5 units. So you need to go 10 units in the direction of this to get over here, right? What's an easier way to do the symmetry for that, though? I mean, so I have points, right? I have, I have 10, 0. And then I have 2, 6. So that's 8, 6. Oh wait, no, this is 10. It's a 3, 4, 5. Oh, very cool. No, it's a 3, 4, 5. Yeah. 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 So, yeah. If this is at 2, 6. Yeah, Reki, I'll get to it, dude. I got a lot of people I gotta work with today, dude. 2, 6. And if this is at 10, that means this distance is 8. This distance is 6. BM is not equal to MA. I believe it is. Because it says AB is a diameter of the circle, and the circle is centered at M. So, if this is 10, this is also 10, which is going to do the same thing of going 8 units this way, 6 units that way. So, 8 to the left is going to be negative 6. Negative 6, 12. Yeah. Yeah. Braden is exactly correct. Never assume drawn to scale. Yeah, I'm not even doing drawn to scale. I'm just doing based on the information they gave me. Which is, they told me that AB is a diameter. M is the center. That tells me this is these two are radii. So BM and AM are both radii equal to 10. Coordinates of C. So this is even cooler, because now this is a right triangle. Where, I know this is 20. Oh, this is really cool, actually. Yeah, watch this. And then I know this is also like a triangle. Which has a height of 12. You could use trig to find the measure angle A. I don't think you need to, though. Or maybe you do. Yeah, because this is a 3, 4, 5. You can, Roman. I might not have time to get to it. Honestly, I gotta run pretty soon here. How's it a right triangle? Because this line is tangent at this point, and tangent to a diameter makes a 90-degree angle. I don't know if I want to use trig. Is there an easier way to do it without using trig? Femvox said the scaling factor is 25 to 16. Where's that coming from? Oh, you use the 3, 4, 5s? Oh, okay. Got you. Oh, wait a minute, Fem. Right? If this right here is a 3, 4, 5, that means this must be a 3, 4, 5, but in the other, like, switch. Right? Because this angle plus this angle have to be 90 degrees. So instead of this being the 4, this is going to be the 3. So this is like 3 times something. This is 4 times something. This is 5 times something. This is 4 times 3. This is 3 times 3. This is 5 times 3. Very cool. So this is 15. Yeah. So, yeah, I agree with point C being negative 15, 0. That's really cool. Right? Because this 3, 4, 5 and this 3, 4, 5, the angles are complementary to each other. That's really cool. Sick. Okay, I'm going to stop there just because I have a lot of other questions I got to do. And I really do have to run soon. But, Poi Poi, I hope you, like, enjoyed this. And, you know, thanks for being patient while we tried to translate from Hebrew.
Nice.
You're all good. Oh, thanks for the follow. Appreciate that. Hey, bro, I think I solved the Beal conjecture. And I don't know anyone smart enough to check my math. And I came to Twitch. Nice. I'm not that smart at math, not at least for the Beal conjecture, but if you want, here, I'm going to shout out someone who is really smart at math. Go check out their stream. Either 2iPie, Zach, he's a good friend of ours. He might be able to help you out with the more heavy, conjecture theory stuff. You're good. Appreciate the follow. Is civil engineering hard in college? You definitely have to take some hard classes. Any engineering major is going to have to take up to at least, I think, vector calculus. So what we were doing earlier on the stream here, if you guys were watching earlier, maybe like an hour and a half ago, some of this might be in your future.
You gotta get in the hospital now. And I just said, just shut up and let me enjoy this pain.
Yeah, so it is painful. You're welcome, dude. Mizan says most colleges require ODEs and linear algebra and sometimes even partial differential equations. Yeah. Ugh. Yeah, so you probably need to do at least DiffyQ, which is it's not a trivial class. DiffyQ is pretty tough. Is accounting hard? Probably not that bad. He's not live right now. I don't think so. If you want to figure out when he's live, we have a calendar of everyone streaming. So here, I'm gonna drop this for you. Yeah, thank you, Shantrix. Yeah, so this is the calendar. So Zach is streaming tomorrow morning at 11 a.m. Pacific time. If you want to go check him out. Here, I'll drop this in the YouTube chat if you want as well. How are you doing? I'm doing great. I'm a little tired, but we're getting through it. Okay. Roman, what's this question? What is this? Are you asking me to like figure out what these graphs are? That's cool, man. Proofs are dope. I like proofs. I heard electrical engineering is hard. Yes. EE is definitely probably one of the harder engineering classes to take just because all the circuit stuff can get pretty nasty. Are there good job opportunities? Well, the job market is all kind of like tipsy-turvy right now. So topsy-turvy. So I don't know exactly. I mean, yes, I would say any sort of engineering degree probably sets you up better for a job versus something that, I don't know. Yeah, a communications degree maybe. You're very welcome. Yeah. You had to take Calc 4 and DiffyQ and PDEs. Oh, wow. And two stat classes. Stats is great. Stats is an awesome class. All right, good to see you, Papuel. Let f be a twice differentiable function. One of these graphs is the graph of f. One is f prime, and one is of f double prime. Ooh, I like this. This is actually really fun. This actually is very related to what we were doing earlier with position versus... If you want to bring it way back to what we did, it was the first question of the stream. We were talking about position versus time graphs and how, like, you can have... Velocity is the first derivative, and the acceleration is the second derivative. Nice. You're only good at physics and math? Well, go for a physics major. Physics is great. And go for accounting. I think accounting's about to get taken out by AI, honestly. I don't really think I would go into accounting. Okay. So one of these is the first derivative, one is the second derivative, and one is the function. I'm going to guess, and then I'm going to check. I think this is what it is. Yeah. Reason being, usually when you start like taking derivatives, things become less complicated. Because it's pretty hard to have, like, really weird, like, curvature changes. 3 is f prime, 2 is f double prime. Yes. And I agree with that. Look, because the slope here, positive. Slope is positive. And then the slope decreases to 0. Here the slope is 0. And then it keeps getting really, really negative. Cool. Until the slope is... I guess 0 here. Yeah, that's cool. And then curvature-wise, this thing goes from, like, concave down to concave up. So the second derivative needs to go just from negative to positive. Wow. That's very cool. How do we prove? It's from the power rule. Yeah, you can think of it that way. I just like to, like, kind of like check points and just, like, make sure it makes sense. Okay. Interesting. Here, this is Equity's question. I assume they're asking for the determinant of this. Are they saying that the determinant of this is equal to 7x? You want to do 13 first? Sure. Find the determinant of the matrix by using expansion by minors. Is that where, like, we start, like, doing this, and then we do, like, this, and then, like, this? Is that expansion by minors? I don't know what my passion is. I like money and learning skills. I like money, too.
My man.
It's okay. Issa, how old are you, dude? How, like, what, you know... Probably have enough time anyways, but if you're in like high school and stuff, like, don't worry, you don't have to be. Oh, that's what they call expansion by minors. Oh, well, yeah, that's my usual trick. Oh, okay. Yeah. So here's what you do. And then you just take the determinant of this matrix. Minors of the row expansion. I think this is what we're talking about. This looks like the usual way to do like a 3x3 determinant. I call it like the T method. Nice. 18, about to turn 19. Congrats, dude. Yeah, don't worry. You're super young, man. You don't have to know exactly what you want to do, but just put yourself on a trajectory where you're doing things that'll give you the most opportunities later to like pivot. So getting like solid grades in any sort of like math and science classes, you don't have to pick right now exactly what science you want to do or what exact engineering you want to do. But if you do well in those, you'll have a lot of opportunities to pivot and switch around. Why do you need the sign matrix? Sorry, what is the sign matrix? What are you talking about, the sign matrix? Here's what you do. You take the determinant of this. So the determinant of this, which is going to be 8 times 7 minus 3 times 9. So it's like this trick. So that's 56 minus 27, which is 29. But then you need to multiply it by this. The sign matrix is, it's because it's positive minus positive. If your teacher makes you do more than a 3x3, yeah, that's really sad. Like, you only ever need to really deal with, like, up to a 3x3. If you're doing determinants of anything higher than a 3x3, your teacher's crazy. Yeah. Alex, what's up, Alex? Yeah, submit a screenshot. There's a website down there. That's what it's doing. 4x4 is the highest? No.
No.
No way. That's just really mean. Bro, because then you'd have to do the determinant of like 3x3s as well. There's more than a 3x3? There is, yeah. Yeah. You can take determinants of infinitely large matrices eventually, but it gets very, very toilsome. Okay. So, yeah, this is going to be positive times whatever this is. You had a 5x5. Okay. Well, if you're going to do row operations to make it look nicer, then maybe you could. But the traditional way to do a 5x5, dude, that's fucking gross, dude. What? I'll show you. Okay. So we multiply positive times -4, which is still -4. This is a bad example because this is 0. So here, let me do 15. 15 is a better example. So you first do the determinant of this. So determinant of the blue square, which is going to be 6 times 4 minus 1 times -3. So that's 24 plus 3, so that's 27. And then you need to multiply it by positive this. So like times positive 5. So just times 5. Okay. So then that's 135. Okay. Then you move this over. And now this is the 2 by 2 you're looking at. It's like this and this. So now you do the determinant of whatever this thing is. And so that's going to be equal to 1 times 4 minus negative 2 times negative 3. Which is going to be, that's 4 minus 6, so negative 2. But then you need to multiply it by this times negative this. So that's negative 1 times negative 3. And so that's negative 6. Yeah, perfect. And then finally... Ugh, why is this not moving? You come over to here. And you look at this. And now this determinant is 1 times 1 minus negative 2 times 6. Okay? So that's 1 plus 12. So that's 13. And then it's times positive 1 times this. So times 2. And so then this equals 26. And then all you do is you just add all these up. So, yeah, 129 plus 26. So it's equal to 155. Yeah, cool. Busy work. Indeed, Femvox. It is busy work, dude. Doing determinants is just busy work. Especially if it's a 4x4, dude. That's
Disqualified.
That's so mean, dude. I wouldn't want to do that. Gross. But nice. Yeah. So I hope that makes sense, Equity. Yeah, the sign thing is just like, you just multiply the top number by plus minus or something. I don't even know how to do, like, I mean, I can count on one hand the amount of times I've done a 4x4 by hand. It's just a math. Okay, let's see. Recky's asking another question. Okay, Recky, but what is this, dude? What? A thin strip of 10 centimeters long is on a U-shaped wire of negligible resistance and it's connected to a spring constant of that. The assembly is kept in uniform magnetic field of 0.1 Tesla. If the strip is pulled from its equilibrium position and released, the number of oscillations it performs before its amplitude decreases by a factor of E is equal to N. If the mass of the strip is 50 grams and that... Oh, Jesus. Okay, but this is like too hard, Recky. What? Are you not in school yet? Are you not like doing things in school? This is like damped oscillation, I think. There's only one way for your physics to get better, Issa. Gotta practice. Ooh, interesting. The resistance is 10 ohms. So that means you're going to lose power. But then don't you also have a force? Because you have changing magnetic flux. Current change in magnetic flux. So as this piece, well, in that case, Issa, I say just like, yeah, just try some things. Get a degree, do some internships, see what stuff you like. So as this strip moves back and forth, it's going to enclose different amounts of magnetic field, and that's going to cause a change in the magnetic flux that is being enclosed, which that's going to be equal to the length of this times the velocity in this direction times the strength of the magnetic field. So this is equal to I. And then if there's current, that current is going to like provide an ILB force on it. So then you get F is equal to I L cross B. If the magnetic field is not negligible, does that mean there will be a magnetic field produced? No, I mean, if the resistance was 0, Braden, then this thing would just oscillate forever. Because what happens is, as the thing moves, it creates a changing magnetic flux, which creates a current. And that current then provides like a restoring force. Oh, but it's proportional to the velocity. Oh, so this is like a damping force, yeah. And then you have resistance, so you're also losing... You're losing current as this is happening. Or you're losing power, electrical power. So the force is equal to BL squared... Oh, B squared... So it's equal to BLV times LB. So that's equal to B squared L squared V. And that's equal to F. Oh, you're very welcome. Yeah, just keep trying things, dude. You'll figure it out. Oh, wait. And this is an I, sorry. No, this is EMF. Right? But EMF is equal to IR. So EMF over R equals I. Okay, so this over R is equal to I. So then F is equal to B squared L squared V all over R. Okay, cool. And this is a damping force. Okay. Okay. So if you were to set this up as an equation of motion, right? Sum of the forces, which is equal to mx double dot, is going to be equal to negative kx, and that's also going to be then minus bx prime. where x prime is equal to v. So in this case, b is equal to b squared L squared over r. This is like a damping factor. And then for something that's damped, the amplitude goes as e to the negative gamma t, where gamma is equal to b over 2m. Ah, okay. Okay. And what do they want to know? How many oscillations? Oh, okay. Well, okay. Something should oscillate with square root of k over m. Wait. Yeah. Omega, no. Period is equal to 2 pi square root of m over k. Oh, okay, okay. All right. So I need... What did I say? We needed to decrease by what? Decrease by a factor of e. So it used to be amplitude was equal to like a naught e to the negative gamma t. So if I needed to decrease by a factor of e, I need a over a naught to be equal to 1 over e, right? Oh, so e to the negative 1 is equal to e to the negative gamma t. So gamma t equals 1. Okay, so then gamma is b squared L squared over r 2rm equals 1 over t. Okay, so then we just plug in some numbers. You always answering so many cool questions. You always answering so many questions. So cool. Yeah. Yeah, this is kind of a trickier one. All right. All right. What do we got? B squared is in Teslas, I hope. Yes, good. Okay. So 0.1 squared. The length is 10 centimeters, so that's another 0.1. Wow, they love these 0.1s today. Over 2, the resistance, I believe, was 10 ohms, 50 grams. 50 grams is 0.05 kilograms, right? Yeah. And that's equal to 1 over t. All right, so let's see what we get. Let's on the calculator. So 0.1 to the 4th divided by 2 divided by 10 divided by 0.05 is that 1e to the minus 4 and then to the negative 1. So that's equal to 10. So t equals 10,000 seconds. But I wonder how many cycles that is. And I know that a single cycle is 2 pi squared of m over k. Did they give me k? Oh, they did. 0.5. Okay. So then 2 times pi times the square root of m, which is 0.05, divided by k is 0.5. Sorry. Okay. So that's the amount of seconds for one cycle. So if I do 10,000 divided by 2, I get about 5,000. Answer should be B. Cool. That's actually a pretty... That's 2 seconds for 1 cycle. So it should be 5,000 cycles. Bless you. Aw, thank you guys. Cool.
Well done.
Yeah, that's kind of a tricky one.
Well done.
This involves, like, magnetic stuff. And also, like, damped oscillations. Oh, man, that's a lot. Okay, cool. Can we do my questions next, please? I gotta go, Nick. I'm sorry. I'm really busy. I did help you out 3 times last week, though. Or didn't I help you out yesterday, Nick? I'm pretty sure I helped you out yesterday. Didn't I? Yeah, I'm sorry. I have to go. I have things I gotta do. Okay, cool. All right, let's close out the stream. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate all the questions. Again, if you're just finding us today from YouTube or whatnot, please drop us a like, follow, all that great stuff. It helps us get more exposure to the channel. Here's our calendar if you want to figure out when we're streaming. So our next stream will be tomorrow. I do have to do it an hour earlier. So tomorrow I'm streaming earlier than usual, but it's at 4 o'clock Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. So come on by. We'll help you out with whatever math and science questions you need help with. Yes. Okay, cool. All right. We're going to go raid someone. We have a lot of friends here on Twitch who also do a lot of really cool math and science stuff, so please feel free to like follow them as well. Who's doing stuff? Colorful TIE Fighter, that's fun. Live Vulcan rocket, dude. Everyone's like building Legos, dude. This is so fun, dude. What? You're all building Legos? Yeah, I don't know. Go say Nerdwino's a cool guy, right? We like Nerdwino. It looks like he's building a thing for a rocket launch. That's cool. Okay, whatever. Go say hi to him. He's fun. Okay. I hope you guys have a wonderful rest of your Tuesday. We will see you tomorrow.
My man.
Peace.